So we created something called expanding recall, which takes our target facts. This would be 3 plus 7 and 7 plus 3. Then we give them 2 facts that they know. It could be 0 plus 1 and 1 plus 1. Then the target facts again, then 3 facts that they know. Now, if you think about, putting these L's on their side, what you get is a perfect expanding rehearsal model with practice in between. So you're getting twice the bang for the buck. Now you've got that small set of facts you're trying to move to long-term memory with that expanding rehearsal, but you're practicing facts that you already know. Now the reason that works is because these take a very, very low cognitive load. This is not new information. You're simply retrieving what you know. Here you're trying to hold in working memory the new information, and it works very well because that cognitive load is so low. So you get twice the bang for the buck. Once you've gone out to, out to this level with the new information, by then it's stored. And we look at the accuracy and speed at which they do that, and then we move it down into independent practice. Excuse me, so that new information is brought in then as the L's. And we just give kids a lot of practice. We like to use games because kids like games. And so these facts would only be those facts that are fast and accurate, under 0.8 seconds and accurate. We don't let them practice anything that they haven't already stored. What's the other advantage of technology? Well, the computer manages all this for you. Trying to do this by hand, and there are programs out there that do exactly what we're talking about in terms of the expanding recall and the low fact. But teachers tell me they spend hours a day just trying to set that stuff up. It's not very practical, but technology is very, very good at it. So what's the effect on that? Well, this is one of the early students that we study. This is David. David is classic. He wasn't the worst student we ever had. He certainly wasn't the best. He was kind of one of those middle-of-the-road kids. He knew his zeros and ones and a few twos, but when we were doing the assessment, anything much beyond 2 really frustrated him. Here he's doing this. So he looks at the problem, starts to count on his fingers, and then decides he's going to use the number pad, or the number line. Starts counting. It's very, very slow for him, all right? Now you're going to see David. David has now had 54 10-minute intervention periods using that FAST model. So he's had 540 minutes of intervention. Now, at this point in time, David has now stored 82 of his 100 addition facts. We know that based upon speed and accuracy of what he's doing. So what you're going to see is what I just showed you. The first thing you're going to see is that expanding recall. He's going to get new facts interspersed with facts that he already knows. So he's got 2 new facts today. And so you'll see a little bit of that. And then the screen's going to flip. And I jumped ahead to the practice part where he's only practicing those facts that we know he's stored. So you're going to see both parts of this program, but shortened, okay? So let me show you this. What you'll notice already is he's much, much faster than he was before. So he's only getting 2 new facts interspersed with the facts that he already knows. He has no trouble with this at all. Okay, so here's practice, and these are only facts that he's stored. You'll notice his response latency is a little bit faster here, which it should be. He's looking out the window to the right. Watch what happens. So Mr. Davis, the principal, walks by and he waves to him, but he keeps these balloons going up with the other. How can he do that? Well, he's freed up so much working memory, he's multitasking, right? He's not worried about those facts anymore. He's worried about Mr. Davis, and he's waving to him. That's a level of fluency we've got to get kids to if they're really going to, have enough working memory to do higher order math. They can't be sitting there worried about what's 3 plus 5. They simply retrieve that and use the working memory that they have available to them for more complex math. Until we get kids this fluent, they're always going to struggle. Now, the good news is most kids can become that fluent. Even special ed kids can become that fluent. All right, we've seen very, very few kids over the years, and we have seen some that I just finally gave up on. I said, this student will never learn their math facts. But I could probably count those kids on one hand, okay? Most kids, you know, learning disabled students, emotionally disturbed students, kids, you know, mild mental retardation, can in fact learn their math facts, all right? And what we found is it works even better for kids that don't have disabilities, all right? Kids that are, you know, those struggling students, those at-risk students, do amazingly well, okay? And once we get them fluent, it makes all the difference in the world in terms of them being able to do mathematics. So that's the good news. The other good news is that the reason you're here today, Tom Snyder's having this breakfast, is they've taken our research and they've published a program called FastMath, F-A-S-T-T, FastMath, based on the FAST model. And it is available now and is being used by a lot of students around the country very, very successfully. We're hearing really great things about how kids are doing. So that's the research. That's why we do it. That's why math fluency is so important if we really want kids to move beyond moving beyond basic math.